So, for NLP, right, so these are the few basically A star are good venues from where you can refer. If you want to see the current state about what people are doing, right. So, you can go to the www, KDD, CGIAR, ICDM, CIKM, TKD, NeuroIPS, ICML, ACL, UAI, SKY, III, CVPR, Colink, Colt, right. So, like that there are many conferences. So, you can get I think A star conferences, top journal venues list you can get. So, A star, B star conferences you can get, right. So, you can refer the papers, recent papers, right, 2024, 2023 papers, and you will understand that what is going on, how the people are working and what problem people are tackling and what type of basically papers are coming, right. So, for example, many papers in NLP basically they are focusing on the data collection. So, you have prepared the data for low resource languages, you have done certain analysis, some analysis, then there is a high probability that you can get enter into these venues, right. So, just this was just information I just gave because someone of you asked that. Just a minute. Yes. So, simple is better, right. So, we want to do beyond explanation that are simples. So, how we basically try to provide explainability in the AI models? You have a real data, you have a trained model, and we generally perform the inference. So, once inference or basically response basically reaches to us, or response is generated by the model, we try to do explanation or we try to explain why we got this response or why this response basically occurred. So, in order to get this explanation, the idea is you have another approach, some algorithm which uses this model to basically try to respond to explainability. So, you have a data, you have basically inference, you have a model with you, you have to explain, right. So, this is the explainable module. So, maybe I can tell you one thing, explainability module can be, so this explainability algorithms can be model agnostic. So, model agnostic means it does not matter what model you have. So, model is black box for you, which just need input and provides the output to you. So, those algorithm directly you design the algorithm which can provide explanation on those models, right. So, we call it model agnostic, right, model agnostic algorithms. Another one is during the model learning process, during when you are designing, when you are basically training the model, you keep on basically explaining the things. So, whenever inference basically is out, it gives explanation, right. So, model itself provides the explanation, and another one is basically at the test time, right, when you deploy the model, you have algorithm which basically try to provide the explanations. So, that's why here you have we have a model agnostic and maybe you can say model specific explanation, right, in agnostic, right. So, and explanation can be provided at a two stage. You can say local explanation, right, and another one is global explanations. For example, ChatGPT, if you want to provide explanations, it might be you need a global or generic explanation. But for a specific task, if you want to provide the explanation, why translation module works, why image generation module works, text to image, right, why basically mathematical computation module works, right, in GPT or you can say in chat GPT or in conversational AI or LLM models, then those are basically you can call it just local explanation, and if you were taking all the things as a whole, right. So, it might you can say the global explanation we are just providing. So, scope and the approaches you know now. So, it might be model agnostic or model independent, it might be model specific, right. So, explanation you can generate for a particular model only, it might not be applicable for all. For example, gradient based approaches. So, gradient based approaches are model specific, if you are able to compute the gradient you can just do it. Something like you can just say that okay, feature importance you can identify even independent of model. So, you just need output, you need input, right. So, using input and output you can just try to get the gradient information. So, that is another story, but if you want to investigate inside the model, like you have grade cam and others, right. So, then they are model specific, only few models basically give this facility, right, not all. So, here black box versus interpretable models, complexity of models, you can say lack of transparency, trade off between. So, these are current challenges that we have, accuracy and interpretability, then local and global interpretability, we want model specific techniques, model agnostic techniques, right. So, increasing responsible AI development and deployment. So, that is the reason people are asking about the explainability nowadays. These are the tools, basically model agnostic or model specific basically methods, visualize and interpret, and you can integrate it. So, LIME, SAP, Interpret ML, AI explainability 360, AI fairness 360, right. So, explain like I am 5, it is yellow brick, what if deep left, and another visualization tool is TensorBoard. So, TensorBoard you have a model and you just call this TensorBoard, it will basically draw the computation graph. So, once you have a computation graph, so computation graph also provides certain explainability inside the model, that how the model is, you can compute the gradient very easily and how the model works, right. You can visualize the computation graphs, you can visualize training parameters, you can visualize the matrix and hyperparameter values, right. And this basically somehow whatever you, if you have visualization, if you have certain understanding mechanism, so they provide certain explainability towards the model, right. So, this is the LIME usage of LIME for text data, how LIME works for the text data. So, you just see that the corresponding text is given, decisions are given, you just see that based on the color on these words, right, they have weightage for every word. So, in that piece of text that you have, so if you apply the LIME model, so it will select those words which has the highest probabilities, or you can say they have higher weight, and based on that they have a color palette, you can say that is pictogram you have. You just see for example, here text with highlighted words, like these words are important, right. So, 0, complaints, mechanics, capitalizing, ignorance, right, account, coverage, weighting, and accordingly you can say weights are here, right. So, you can say that what is the weight of word 0, what is the weight of second word, what is the weight of third word, fourth word, and so on. For positive, for 0 class, so if you want to predict anything as a 0 class, so what is the importance, what are the weights, or you can say values for the features that are important. In order to predict class 1, so these important features are there, complaints, mechanics, right, and so on, you can see their weights are there, you can say, and based on this, right, you can decision is made. So, this type of report is basically report is generated when you apply this LIME tool or LIME package on your model. So, any model you can just take and you will just apply this LIME approach, LIME basically package, LIME algorithm, and you will get explanatory like this. Then say for shape features, shape library is there, right? Shape library is there for eminence data. So we have demonstration. We'll show in the next post basically lunch session. So you just see that how it is basically giving the explanation. So you saw the why 7, its the model is saying 7, why model is saying 2, why model is saying 1, 0 or 4. So it basically try to get the shape features, right? And most of the gradient, some gradients are also used here by the way, but it try to get this one. Then you can say fashion data. For fashion data, if you apply this shape data, so you can say this how the features are here. So what are the regions which are important, what features basically it basically generated, and maybe if you are working in that, you might have seen this one. Why you are saying that this is a sandal? So what are the features? Suppose the first image you just see. So what are the features basically made this a sandal? What are the features? You can say this is a bag. What are the features by which you can say this is a T-shirt? The first image. You know this is shoes, right? But you can say that what are the features which might try to tell this belongs to certain different classes, right? And the stronger the probability of the class, it will decide. So this type of visualization you can just see, and of course if your model is not learning anything, so it will not have a different color, different intensity, everything will be of the same color, right? You know that there is no decision making happening, model is bad. So likewise here you can see that this basically SAP applied on ResNet 50 model, and you know that ImageNet data. So yesterday we have discussed that it was trained on 1000 images, right? 1000 class data, including chair, table, and lot of objects, object classes are there. So you have a original image here. So if you want to get the prediction, apply the GradCam, just compute the GradCam heat map. So where are the gradients? You can say important gradients. So accordingly, this color, the dark brightness of this color, you can identify. So you can say that at the face, can you see that most of the brightness is at the face? So facial feature are important to tell whether this is basically this belongs to certain category, cat category or not. Then you can just superimpose the image here. You will see that what are the features in the image it basically looks into. Gives more priority, right? Then it basically tells about the Egyptian cat, and you can see the probability here. So class index is 285. So this model was ResNet 50 model has 1000 classes, right? So output layer has 1000 output, 1000 classes, 1000 neurons, and the neuron which has the higher activation value, or you can say highest value, so that class is assigned. So here Egyptian cat has a 0.45, you can say the 45% I can say value out of 1000 classes, it has 0.45 value, and this is the highest one. If you want to display, you can display all these probabilities, right, for all the classes. Now can you say why the model works? This gives certain explainability, right? Why the model works, what are the features, right? So this is one of the GradCam, right? So approach, you can get the heat map. This is another data. So where you have certain basically images, these are the medical images, and bacteria are different class of basically bacteria are there, right? So you can see different type of infections you can see here, right? And why the model works? You can use Lime, you can use SAP approach, and they will give you the region from where the features are extracted, right? So important region in the image, and if you see that region is just a garbage, that is not useful, that is not ROI, right? So region of interest, then you say that model is not working well. But if you see that it is looking at a place which is basically ROI, region of interest, then you can understand that model is working correctly, right. So, this methods basically gives certain explanations, but you might rely on always on these things, right. For complex models it is very hard to get it right. Okay, what is the time right now? So, maybe 11:41. Maybe we can discuss few questions, right. So, one of the question I think there was there is, I think GPT, what was the question? So, I forget. So, नहीं अभी वाला जो क्वेश्चन आया था किसी ने भेजा है राइट लंदन ने जो क्वेश्चन तुम क्या था so on LLMs right so see interpretability on LLM is of course the challenging process. So they said that can be get citation based response right. So like in Gemini if you see Gemini right so if you perform a query on Gemini so it basically gives you the source right. So from where basically data is collected response is made. So there are variants of course ChatGPT you can train in that direction. So you can put the evidence there. Even nowadays people are customizing it with the certain evidence based response generation. So whenever you say that ChatGPT or any LLM basically provides certain response, so what is the evidence? Suppose you say that okay some response is made for a certain query and it provides the evidence. So in the evidence let it basically gives you the evidence that is you know that is biased towards certain thing. From evidence you might know that whether the evidence is basically trustworthy or not. So most of the time suppose I say news article. So whenever it comes the problem is basically fake news or hate speech detection or fake news detection. So how can we detect fake news as a human? What is the idea? So given a news maybe 1 or 2 or 3 sentences. So as a human how do we rely on that? We see that source who is providing the news right from where we are getting. So if it is authentic trustworthy basically news website right, or the information that is we are getting is from trustworthy persons, we rely on that. So in order to detect the fake and basically non-fake or genuine information, we have to rely on the source of the information. So generally what happens, so we try to basically crowd you can say just collect information from many sources, don't rely on one source, then based on the majority voting you just say that the news might be correct. But many times we do not rely as a human, if something is not acceptable right in some sense, as a human we know that what might be obvious, what might not be obvious. Some common things might happen. So suppose you know the pattern or some perception in the community you have against certain people, certain person, then if something happens then you know that person can do that thing right. Many times if you know that some intelligent kid is there in the society and you say that that kid is basically selected in some of the top rank venues. So people know that it is obvious the student is genius and he has been selected. But if you know that some student is there and that student that kid is basically very not intelligent in that sense, and you found that someone said that he got selected somewhere. So that might not be obvious for you. You will say how did it happen, right? So there are things, right? So the source of information and the perception, the beliefs that we have, based on that we basically rely on the news. So generally what we do, so generally we try to verify. So there are, if you have a strong perception, you will not go for verification. But if you have little gap, little doubt, you will try to verify, right. So, you have source of information, even given the source, right, trustworthy source, you will try to verify, right. So, that is the story, and this is basically giving a lot of harm to the society. We are learning this CPS system, but you can say this is another security threat, that fake news, basically spreading fake news. So, spreading fake news on social media sites basically tries to basically opinion shift. It basically decides on opinion shift. So, suppose you have spread certain news against certain celebrity or certain personality or certain person who has certain fame in the society or somewhere. If you spread fake news or bad news for a person, so if 1 or 2% rely on that news, right, then it basically harm that person. So, that is why fake news or these AI systems, that most of the time you can say AI systems are generating these fake news, right. You can say that fake videos, cloning, voice cloning, right. So, lot of things are there, so they are harming the system. So, we have to prevent it. So, in CPS, in addition to see that what data the models are stealing, what type of basically decision making the models are basically changing, we have to look into this aspect as well. But at the same time, if we say that we cannot, we should not do research, right, to generate the model, to generate the data, then you will not be able to compete with the current state of art, right. If you do not start using LLMs, if you do not start developing LLMs, so we will be the just user, right. So, if you want to compete with the current state of art, similarly you have to chase that, right. So, you have to work, you have to basically follow the research, current research that are going on, and accordingly you plan, right. So, that is a challenge here. So, evidence based solution is of course the need. So, citation based, I think her question was evidence based, by the way. So, we need response. So, that basically tells us the explainability, that explains, because we have collected this data from this source and we are giving the response based on that. Like in Wikipedia, you have a lot of evidences, right. So, a lot of citations are there, and if you see that those citations are trustworthy places or trustworthy venues where the paper or the article were published, you will rely, right. But if you say that some basically place, or you can say some organization which is not trustworthy maybe, then if you say that center or that basically organization is spreading certain news or sharing certain news, that might not be correct. And this is a human perception, right. If we trust on a person, we trust. If we distrust, you say that okay, person is not trustworthy, so you will never trust, right. Are you getting my point? So, this is a true story, and so trustworthy AI is very important. Explainability basically is the way you can trust on the AI models, right, and we want to build our trust on AI models. If you do not have trust, you will not use. So, huge market is there, right. So, if people do not trust on your AI model, let DeepSeek is there and ChatGPT is there. So, let both are commercial model. So, we do not trust on let DeepSeek, let you only trust on Microsoft or OpenAI, then people go for OpenAI ChatGPT, right. So, that is a trust building. If you basically break the trust, or any organization, any society, any person, any object basically somehow breaks the trust, then that thing is not trustworthy. You never have a confidence, right. So, that is the story here. So, we will do these are the few popular tools, and maybe we will discuss few more tools in the post lunch session. And now I think we can discuss more on your problems. You just ask whatever you are doing, we can discuss on those problems, right? So post bid session will have a half an hour discussion, right? So where you just whatever problem you are facing, we can discuss on that, right? You just prepare your questionnaire, so we can do certain discussion, right? In the post lunch session. So we are stopping here and we'll meet, right? So we have code, we will share the demonstration codes today. Okay. So by the way, we have one more module in the demonstration session, that is basically network security. So we have lot of modules there. So you have intrusion detection system, malware detection. We have code for that. Password breaking. So how can you do brute force? How can you basically generate the password? So for sort of things you can do. So few codes we have. I'll share you. You just go and practice. There are few bugs. I have intentionally put the bugs. You just try to remove and you just try to play, right? So don't worry. So in the post session, we'll do some fun, right? We'll do some experimentation. Thank you everyone.